What's up, people? Welcome to the session. Welcome. My name is Anoop and this is Vedantu. I hope you guys are doing good. What is new in life? How is everything going? I hope all of you guys are having a fantastic, fantabulous, super awesome day. What is up? Hello. What's up, Aditi? How you doing? Hi, Ayushi. What's up? Welcome, people. All right. So again, I hope you've been having a wonderful day so far. So today we'll be doing the top 20 questions for term 2 examination of magnetic effects of electric current. This is the first session of that. We have done 2 sessions of electricity before this, so if you haven't checked that out, please do, because we have done some amazing set of questions, and trust me, you would definitely find that helpful with respect to your term 2 preparations, right? So majority of the class is going to happen on Mentimeter. So who was wondering, will there be Menti quizzes today? Absolutely yes. We will have a lot of Menti questions, about 10 to 15 questions of Menti will be doing that, after which we'll be coming to the subjective type questions. All right, so people, are you all ready? Can I get a oh yeah in the chat box? Good afternoon, good evening, good night, whatever time you're watching this. Hello, Sat Sri Akal, how are you doing? Peace. Yeah, hi Aditi, what's up? How are you doing? Hi Darshika, what's up? Oh yeah, that's it, people. That's it. All right, then. So let's get started, because we've already, and yes, people, if you guys want to follow me on Instagram, that's my Instagram handle, Anoop_Vedantu. I'll be putting up all the leaderboards. I haven't done it yesterday, so today I'll be putting up all the leaderboards of today's quiz and yesterday's quiz on my Instagram story, so you can check that out as well. So that said, people, let's hop into the Mentimeter. But before that, yes, the Drona batch has already started, people. So if you guys are looking for a final revision to kickstart your preparations, Drona is a very good choice for you people to kickstart your preparations. The link for that is given in the description. I'll tell you about that towards the end after the questions are done, right? So let's go on to the questions and let's try to do some questions for today, right? So people, join the Mentimeter. Go to www.menti.com, menti.com, and enter the code 48319145. All right. So once you're in, please let me know. All right, people, come on, let's go. Go to www.menti.com and enter the code 48319145. It's given on the top right corner. Check it out for yourself. Go to www.menti.com and enter this code and join the quiz as soon as possible, because we have a lot of questions to get through, about 20 questions in total from magnetic effects, which is a lot of questions. So quickly join the Mentimeter so that we can begin today's session. Let's go, people, come on. All right, guys, let's go. Who is in right now? Who is watching the video on YouTube? Open up a new tab, either on Safari or Google Chrome, whatever website you're using, whatever browser you're using. Go to that and enter www.menti.com, menti.com, menti.com. Once you enter into the menti.com, they'll ask you for a code. Enter this code for today, 48319145. All right, that's how you join the quiz. I have 3 different Mentimeters, so do not feel bad, because we have 3 different winners for 3 different Mentimeters. So try your very best and try your best to get all the answers right. All right, so shall I start? So electricity case-based question part 1 is of 40 seconds. What is it, Namandeep? Case-based questions of part 1, is it? It's only 40 seconds. Oh, all right, Namandeep, I'll just check it out. 1 sec. Let me just take a screenshot of this one. All right, I'll check it out. I think there's some error there. I'll get it corrected. Thank you, Namandeep. Thank you for bringing to our notice. I thought they corrected it. I actually went and told them that you have to correct it. I guess they have not corrected it yet. All right, I'll get it corrected. Don't worry. All right, by the end of today, I'll be done. Okay, so people, let's get into the questions. Then here is your first question of the first 20 questions. Here's the first one. The nature of magnetic field lines passing through the center of current carrying circular loop is what? So what will be the magnetic field lines of a circular loop when you talk about the center? When you go to the mid region of it, what does it look like? Options are, does it look circular, ellipse, parabolic, or straight lines? When you talk about a circular loop, circular current carrying loop, what does the magnetic field lines look like when we talk about the center of that? All right, 5 seconds, people, go ahead and answer this. Sure, Nami, thanks a lot, buddy. Thank you. All right, wonderful, people. Wonderful start. Absolutely fantastic. Yes, it is going to be straight lines. Why? Because towards the center, the magnetic field line is getting more uniform, right? Because the magnetic field lines are acting from magnetic force is acting from all the directions, because of which it becomes uniform, and because it's uniform, it almost resembles a straight line. So that's the answer for the first question. Fantastic start, people. Kushagra on the top, followed by Musk class 1. All right. I mean, Elon Musk, Vasundhara, followed by Aishi, then it's Kushi, Shrishti, Nevin, Karthik, Anoop Sir. No wonder. Sitanshu, congratulations. Well done, people. Good start. That is the first question. Moving on to the second question, people. Here we go. Second question on your screens. Let's go. Whoever is joining in right now, please join the Mentimeter as well. Go to www.menti.com and enter the code 48319145. The magnetic field near a long straight wire is described by straight field lines parallel to the wire, straight field lines perpendicular to the wire, connective circles center on the wire, or radial field lines starting from the wire. What does the magnetic field lines look like if you talk about a straight current carrying conductor, a straight wire? What does the magnetic field lines look like as a question? Go ahead, guys, come on. Connective, it should have been concentric circles. Connective, concentric, it's very what to say, you can say that the circles are one after another. So connective or concentric, so sometimes they interchange the words. Sometimes it's called as concentric circles, sometimes they call it as connective circles also. So in time and again they call it as connective circles as well. Sometimes they also call it as concentric circles. So don't get confused, it pretty much means the same thing. So fantastic job, people who got confused. It's actually concentric circles or connective circles, in the sense one circle after another, one circle after another, it goes on like that around a straight current carrying conductor. That is what the magnetic field lines look like. Fantastic job again, people. 11 if you guys got the right answer. Super duper amazing. 2 with option A and 1 with option B. That's not a bad number at all, people. So here we go. Once again, the leaderboards. Kushagra still on the top, followed by Vasundhara, followed by Musk. G unfortunately got the right answer. Sorry, wrong answer. Musk, what is this? Shame, puppy, shame. You can launch SpaceX and all, can't answer a simple question. What is this? Then you have Kushi on the second now, Vasundhara on the third, Aishi on the fourth, then it's school teacher, Karthik, Shrishti, Invincible Linker, what's up Linker, how are you doing? Sitanshu, and then Musk. Wonderful, guys, wonderful. Moving on to the next question, guys. The third question for the day, people. Pay attention, here we go. Third question, let's go. Tesla ji. Don't believe everything AKSO says now. Okay, here's the question. A current carrying conductor placed in magnetic field experiences a force. The displacement of the conductor in a magnetic field can be increased by what? Options are by decreasing the magnetic field, by decreasing the current in the conductor, by increasing the magnetic field, or none of the above. You know that when a current carrying conductor is placed in a magnetic field, that conductor will experience a force. Now the question is, the amount of displacement, the magnitude of displacement depends on what? Fantastic, guys. Super duper amazing. Proud of you people. Now, basically, people, they're talking about Lorentz force here, and we know that Lorentz force depends on 3 factors. One is the magnetic field, the strength of the magnetic field. Second is the length of the conductor, and third is the amount of current flowing through the conductor. So option C is the only thing that makes sense, and you guys have done a fabulous job there, people. Fabulous job. That's more than 90% of the class, by the way. Super awesome. Here's your leaderboard once again. Kushagra still on the top, not giving up his position. Second is Kushi. Third is Vasundhara, then it's Ayushi. No, wait, second is Ayushi now, third is Vasundhara, fourth is school teacher, then it's Invincible Lincoln, followed by Kushi, then it's Karthik, Sitanshu, Musk was the fastest to answer, and then Nevin as well. Fantastic. Exactly, Tesla, exactly. Alright. Okay, so that is the end of the 4th question, people. So 3 questions done. This is the 4th question for today. Pay attention, give your best. Again, try to answer these questions to the best of your knowledge. Alright, don't ignore these questions because the same question might appear in your boards. Electric motor converts what to what? Options are mechanical to electrical, mechanical to heat, electrical to heat, electrical to mechanical. What is the kind of conversion that happens in an electric motor? Very simple question again. Awesome job, people. Awesome job. This one, though, is a super duper easy question. This, even if you have not understood the entire chapter of magnetic effects of electric current, you will still be able to answer it because you have already studied this in your lower grades. In a motor, people, electrical energy is what is converted to mechanical energy. When you turn on the switch of a fan, the fan blades start to rotate. What is that? That is mechanical energy. And what is happening because of the passage of electricity? The motors converting that electrical energy to mechanical energy. Very simple question. Some of you guys still got it wrong. See guys, mechanical to electrical can be electric generators. Electric generators work on that principle. They are converting mechanical to electrical. But motors convert electrical to mechanical energy. Don't get that confused. A basic question, that is. Do not make these silly mistakes. Your exams are coming up pretty soon, so try to avoid these type of silly mistakes, right? Anyways, leaderboards once again, I think it's the same. There's no change whatsoever. No, Vasundhara, full-on competition for the second position. If Kushagra is not letting his position go, if Kushagra is still on the top, second is Vasundhara, then it's School Teacher, then it's Invincible Lincoln, followed by Karthik, then it's Ayushi, Kushi, then it's Sitanshu, Musk, and then Nevin. Fantastic, guys. Fantastic. Super awesome question. All right, last and the final question. For the first question, we have 2 more questions to go through. And who is joining in right now, please join the Mentimeter. The code is 48319145. All right, last question for the first question. Pay attention, 100% focus. Here's the question. The electric motor to make coil rotating continuously in the same direction. Current is reversed in the coil after every half rotation by device called as what? Options are carbon brushes, commutator, split ring, or armature. Okay, guys. Okay. Go ahead and answer this. Okay, it actually makes sense. Okay, I read it wrong for a second. Okay, options, people. Carbon brushes. It's slip ring, people. It is slip ring, not split ring. Even I read it wrong at first. It is not split ring, it's actually slip ring. Slip ring is there in generators, not in motors. The whole point of why the current is getting reversed is because of split ring. Slip ring is something that you have in your generators. It does not change the direction of current. Whereas a split ring, on the other hand, does change the direction of current, and hence commutator or split ring makes more sense, but not slip ring. Slip ring is there in your generators. Since generator is not a part of your syllabus, most of you guys would have skipped through it. Maybe because of that you did not get it right, but it's actually split ring, guys. All right, small confusion there. First I thought, okay, even I might have gotten it wrong, but no, it's actually slip ring because it's very small. Maybe you've not seen the words, but yeah, it's actually slip ring. The correct answer should have been split ring. All right, because it looks like a ring which is split into half, no? So it looks like that. Okay, but nonetheless, top 10 though, not much change. A couple of you guys got it wrong. Lincoln, Ayushi, Kushi, and Sitanshu got it wrong, but Kushagra is still on the top, and hence the winner for the first quiz time. Fantastic job, Kushagra. Fantastic job. Second is Vasundhara, then it's School Teacher, then it's I'm not able to read the rest of the names. Then we have Musk, followed by Lincoln, followed by I'm not able to read it. Then it's Kushi, Nevin, and Sitanshu. Not bad, guys, not bad. But yes, the last question, slip ring is something that you have in your generators. All right, it is there in your generators. That will not change the direction of current. Slip rings do not change the direction of current. Split ring, on the other hand, does change the direction of current. All right. Okay, moving on to the next quiz time, people. The next 5 questions will be happening on another Mentimeter. So the code for this one is 29393049. So you can just leave that Mentimeter, open up a new website, or just enter the code again. 29393049 is the next code. Enter the quiz. We have another 4 questions that'll be happening over here. Let's go. Yes, Nidhi, what's up? How are you doing? Exactly. The other name for split ring is commutator. Why is it called as commutator? Because it is changing the direction of current. Because it's changing the direction of current, it's also called as commutator. All right, it's okay. It happens. I know. Yes. You see, if you talk about if you talk about AC motors and all, that would work on slip rings. But in our syllabus, we don't have AC motors at all. We are only talking about DC motor. In a DC motor, we are using slip rings. If it is an AC motor, then it would have been a different case. In AC motors, that would have been a slip ring instead. But we don't have that in our syllabus. We are only focused about DC motors, and there we're using split rings. All right. Okay, people, let's go ahead and enter the code once again. 29393049 is the code. Once you enter in, please let me know. We'll start with the quiz. Majority of you guys are here. I'm going to start the quiz, people. The 4 questions, the next 4 questions we have in store, the 6th question in total. Let's go. Here's another one. The question states, which of the following factors affect the strength of force experienced by a current carrying conductor in a uniform magnetic field? Options are magnetic field strength, magnitude of current flowing in the conductor, length of conductor within the magnetic field, or all of the above. Which of these factors would affect the magnitude of force or the strength of force acting in a straight current carrying conductor placed in a magnetic field? Fantastic, guys. Fantastic. Absolutely correct. This is something, again, we've already done the same kind of question before. Please remember this, guys. This is called as this is nothing but Lorentz force. And the Lorentz force, the whole formula I told you, there's only one formula in this chapter, and that is Lorentz force, which is what F is equal to BIL. According to this formula, B stands for magnetic field, I stands for current, and L is the length of the conductor. So the force acting on a current carrying conductor depends on these 3 factors. Nothing else. The length of the magnetic field, how much current is flowing through the conductor, and the strength of the length of the conductor and the strength of the magnetic field as well. All right, fantastic, guys, fantastic. Please avoid that confusion. There's only one formula. Please don't forget that, and that is that one formula. All right. Anyways, Savani, last time third. Oh, is it? Hi, Savani. Welcome back. So, what is AKS's wife name? It's Mrs. AKR. Then we have Kushagra, Jashwant, Musk, class LKG. From first standard, now you went to UKG. How are you going down? Followed by Ayushi, then it's Srishti, Harisharam, followed by Vishnu and Nevin. Fantastic, guys. Fantastic, people. Moving on to the second question. ICA students, you guys can also join because you still have all of these in your syllabus as well. Second question, go ahead. The code is 29393049 if you're just joining in right now. The next question, people, 7th question. Magnetic lines of force inside a current carrying solenoid are perpendicular to the axis, along the axis, and are parallel to each other, parallel inside the solenoid and circular at the ends, or circular. When you talk about the magnetic field lines about a solenoid, what do they resemble like, or what do they look like? Perpendicular to the axis, along the axis, and are parallel to each other, parallel inside the solenoid and circular at the ends, or circular. Let's go, guys. Let's go. Is it Jacob? How is it? Santoy Jacob, how is it up? Hi Antara, what's up? Yes. Alright. Are fantastic, guys. Fantastic. Because see, guys, the one good thing about solenoid is that the magnetic field lines of a solenoid is very much similar to that of a bar magnet. So if you remember the magnetic field on a bar magnet, this should be very, very easy. So as the option says, inside the solenoid, the magnetic field lines are parallel to each other because it's uniform and it is pretty strong as well. But outside, they are actually circular in nature. So they are outside, they'll diverge. They'll start from the North Pole and end up in the South Pole. But inside, they're all parallel to each other. Fantastic, guys. Fantastic. 21 of you guys got the right answer. Super amazing. Proud of you guys. Fantastic job. So here's your leaderboard once again. We have, what is AKS's wife name? Ask him now. Why are you asking me? Ask Abhishek, sir. No, if he says it, then I'll accept it. Otherwise, until then, I'm going to keep saying this only. It is Mrs. AKR, that's all. Mrs. Abhishek, that's all. Jashwant on the top, who was the first to answer, then it's Kushagra, Ayushi, Harishram, Karthik, Shrishti, Sitanshu, Shekhar Naik, followed by Vasundhara and Mahima. Wonderful, guys. From first to the 9th position, such a sudden drastic change. Moving on, guys. Moving on to the next question, the third question for the second quiz time. Here we go. The question states, which option explains Fleming's left-hand rule to understand the working of a motor? When a current carrying conductor is moved with a force, it creates the magnetic field. When a conductor is moved inside a magnetic field, current is produced in the conductor. When the magnetic field is moved relative to the conducting conductor, current is produced in the conductor. When a current carrying conductor is placed in a magnetic field, it experiences a force by that magnetic field. Which of these would actually help you understand, or where do we use Fleming's left-hand rule is the question. Let's go. So he doesn't tell us, probably he's shy. Why would he be shy? Why would AK be shy? Da? Have you ever seen AK being shy? Huh? Alright, 21 of you guys got the right answer. Absolutely wonderful, guys. Absolutely wonderful. No doubt it has to be option number D, because we know that if this is a magnetic field, let's say this is a horseshoe magnet, I have a magnet of a conductor and the current is flowing through the conductor. If I place it in a magnetic field, this conductor will experience a force, and that direction of force is what is shown by Fleming's left hand rule. Fantastic, guys. If you're still confused about it, I have made a video on Fleming's left hand rule and right hand rule, both the working of motor and EMI. Check it out, people. It's there. It's absolutely free. All you need to do is spend some time into it. That's all. Anyways, Kushagra back on the top. Kushagra, what you sneaky little killer. First is Kushagra, second is Harshanam, who was the first to answer. Then it's Jashwant, Karthik, Aishi, Sitanshu, then it's AKR's wife name, then it's Vasundhara, then it's Lincoln, followed by Shushti. Fantastic, guys. Fantastic job. Moving on to the last question for the second question. We have another quiz time as well, so do not leave yet. The next and the last question for the second question. Here we go, people. The code is 29393049. Select the correct statement. A stationary charged particle in a magnetic field experiences a magnetic force. Fleming's left-hand rule is applicable only for negatively charged particles. The direction of velocity of charged particle is always perpendicular to the direction of the magnetic field. And option D is the direction of force on a current carrying conductor is dependent upon the direction of current and the direction of the magnetic field. Which of these statements are correct? I'll repeat the question once again, guys. I'll repeat the statements one more time. The first statement states a stationary charged particle in a magnetic field experiences a magnetic force. Fleming's left-hand rule is applicable only for negatively charged particles. Fantastic, guys, fantastic. But technically speaking, if I have to just make a small correction here. See, guys, if you talk about, this question, this is the question, right? See, the direction of velocity of the charged particle, okay, so that is the thing, guys. So if you use your Fleming's left-hand rule, the particle's motion and the magnetic field is also perpendicular to each other, isn't it? The motion of the particle and the magnetic field is also perpendicular to each other, according to Fleming's left-hand rule, right? That's what it says. So technically speaking, both option C and D are correct. Both options C and D. D is absolutely correct. There's no doubt about it. But C is also correct. Why? Because the particle's motion and the magnetic field is also perpendicular to each other. That is when you get maximum force. If they're parallel to each other, then the force is zero. All right. So option C is also technically correct. So I'm just going to give marks for that also, because there's a small confusion here. So I'm just going to give that as the correct answer, people. One sec. Just give me a second. Option C is also technically correct. So I'll just choose option B as well as C. All right. So anyways, congratulations to all those who got option C and B as correct answer. C and D is the correct answer. Well done, people. So here is your final leaderboard for the second quiz time. We have Kushagra still on the top. Second is Harshanam. I don't think there's going to be any other change. I think it's going to be set in stone. Yes, there is. All right. Kushagra, once again, back on top. Fantastic. You have clearly proved that the first time you got the first position was not by luck. Fantastic job, buddy. Second is Jashwant. Third is Harsharan. Then we have Lincoln, followed by A. Then we have Vasundhara, I believe. Then we have Shrishti, followed by Kushi, followed by Nevin, and then Mrs. AKR. Congratulations, guys. Congratulations. Well done. Once again, well done, Kushagra. All right, moving on to the next quiz time, people. Let's try to do these questions also very quickly. So once again, please join the Mentimeter. This is the last set of questions on Mentimeter. Then we have few more questions left out. We have done about 9 questions. In total, we have about 20 questions. So I have a lot of questions left out. Moving on to the next quiz time, people. The code is 64270691. 3 questions, that's all. After which the other questions that we have are all going to be subjective questions. All right. So quickly join the Mentimeter again. Come on. Hi, Chenmai. What's up, Da? How are you doing? Hello, Naman. What's up? How was it, Naman? How was it? How was your pre-boards? So can you change it for Menti, please, sir? I marked it, Da. Yes, Aditya, I did it. Don't worry. Sure. Yes. Vidisha, I'll give you my email ID towards the end. Don't worry. Just remind me once, all right? I'll put it towards the end. I'll just type it out. I'll just write it out. Hi, Sakshi. What's up? Hi, good game, Anashant. Guys, join the quiz, all right? Join the quiz quickly. The code is 64270691. I don't want anyone to miss out on it. We have 3 questions. We'll have a new set of winners. So go ahead and join this, all right? Oh, is it? Sure, sure. No. All right. Hi, Niveda, what's up? Hi, Vishnu, what's up? Hi, Chidbhai. Hi, Sakshi, what's up? I'm good, I'm good. मैं तो बढ़िया से भी बढ़िया. How are you guys doing? I'm good, Modi ji. Chana ke din, how are you? Like answering all different types of language. Hi, Shika, what's up? It's okay, no worries, no worries. Welcome, guys, welcome. All right, so people, I'm going to go ahead and start the quiz. If you're just joining in right now, please join the code. The code is 64270691. Moving on to the first question for the last quiz time. 3 questions in store. Here's the first one. A current through a horizontal power line flows in east to west direction. The direction of magnetic field at that point is directly above it is. The direction of magnetic field above it, at a point directly above it is what? From north to south, from south to north, from north to south, from east to west, or from west to east. All right. A current through a horizontal power line flows in east to west direction. The current of the magnetic field line is pointing directly upwards. The magnetic field lines are pointing upwards. So what is the force on the current carrying conductor? What is the direction of force on the current carrying conductor is the question. Options are from south to north, from north to south, from east to west, or from west to east. All right. Unfortunately, when I read the question for the first time, I read it wrong. My bad. Okay, fantastic. I mean, I understand this confusion, south to north, north to south. Okay, let me just explain this, guys. Listen carefully. Let me just go to this question and show it properly. See, guys, here's the thing. If you look at this question, no, current is flowing from east to west direction. East to west direction. So middle finger from east to west. That is from right to left side. East to west. Right side is generally your east. Left side is your west. So east to west is your direction of the current. Magnetic field is pointing upwards. Magnetic field is pointing upwards. All right. So your index finger is pointing in the upward direction. So what is the force on the current carrying conductor? It is going away from you into the page. So if this is south, this is north. The east, west, north, south. So from south to north would be the right answer. Got it? I'll just explain it one more time. Listen carefully, people. Magnetic field is directly upwards, pointing upwards. All right, this is the direction of the magnetic field shown by my index finger. Current is going from east to west, from my right hand side to my left hand side. That is the direction of the current. So what is the direction of the force on the current carrying conductor? Into the page, which means from south to north. East, west, south, north. That's how it's going to be. All right. And hence, guys, the right answer would be south to north, not north to south. All right, slight confusion, I understand it, but I hope it makes sense now. Again, guys, these are the type of questions that you need to practice for your term 2 examinations. Why? Because these are for sure going to be asked in your boards. For sure you'll have application based questions like this. So the more you're clear with these concepts, the easier it gets. The leaderboard is completely changed. Cover on the top, followed by word code, followed by num and pre-boards done. I know, buddy, that it's Sinmay Ayushi. Yes, I do have 11 fingers. I do. Kushagra Sneha, followed by Sitanshu, and then Ribbit. Congratulations, guys. Congratulations. Fantastic job. I know a couple of you guys made some mistakes, but I hope it's clear now. East, west, north, south. So if it is into the page, then it's south to north. If it's out of the page, then it's north to south. That's how it's going to be. All right. Okay. Second question, people. Go ahead and answer this. Who is joining in right now? Please join the Mentimeter as well. The code is 64270691. A cylindrical bar magnet is kept along the axis of a circular coil. If the magnet is rotated about the axis, what is going to happen? A current is induced in the coil as the magnetic flux linked with the coil changes. A current is induced into the coil which after some time reaches a saturated value. No current is induced in the coil. A current is induced in the coil and its value reduces gradually. Which scenario is correct? You have let's say you have a solenoid, you have a bar magnet, you put the bar magnet inside the solenoid and you're rotating it. What would happen in that scenario is the question. So pay attention. Yes, Chinmay, I'm from Karnataka. I've been in Karnataka for my entire life. All right. The answer to this question, unfortunately, guys, is actually option number C. I'll tell you why. See, guys, you know that for current to be induced in a conductor, there has to be a changing magnetic field. All right. So if I have a solenoid and if I place a bar magnet inside the solenoid and I rotate it, the magnetic field lines that are there, aren't they constant? The number of magnetic field lines being intersected or intercepted by these current carrying conductor, that is a solenoid, will it increase or decrease? Will it increase, or do you think it will decrease? No, it doesn't. It remains exactly the same, because the number of, again, the magnetic flux, or you can say, don't think about magnetic flux, the magnetic field lines, the number of magnetic field lines getting intersected are going to be the same. When you rotate it about your axis, if you just rotate it, there's going to be no change whatsoever. So that means no change in the magnetic field, which means that there'll be no current induced in the coil. If you want current to be induced in the coil, there has to be a change in magnetic field. Oh, that means if you can move it backward and forward, then there's a change in magnetic field. But if you rotate it, the number of magnetic field lines are getting intercepted are constant, which means there's a uniform magnetic field, which means that there is no current induced at all. All right. I know. I think, yes, that happened. Yeah, exactly. It has to be to and fro. But it cannot rotate. If you rotate it in the same position, then there's no current induced at all. Maybe, I would have told it wrong, but whatever it is, that is the scenario, guys. So get it corrected now. Get it corrected right now. It's a void. Anyways, Kavan, Nevin, Naman, Chinmay, Ayushi, and 11 fingers unfortunately chose the wrong answer. Sneha on the top, Sitanshu, then it's Ribbit on the third position. Fourth is Shami, who was the first to answer, and the rest remains exactly the same. Kavan, Nevin. Then we have Naman, Chinmay, Ayushi, and 11 fingers. Fantastic, guys, fantastic. But yeah, that was rather disappointing. But it's a really, really good question. So please don't forget it. All right, really good question. So please don't forget. These are the special kind of question that can be asked in your boards. So please don't ever forget that. If it's rotated about an axis, then there'll be no change in the magnetic field. If I've told it wrong, guys, please correct it right now. That's the right answer. All right. Okay. So two statements, people. The first statement is charges experience force when they move at right angles to a magnetic field. Because statement number 2 is a moving charge produces an electric field only. Options are statement 1 is true, statement 2 is true, but 2 is not the correct explanation for statement 1. Both statements are true, but statement 2 is not the correct explanation for statement 1. Statement 1 is true, but statement 2 is false. Statement 1 is false, but statement 2 is true. Go ahead, people. Super easy question again. Let's go. It's okay. But I hope you get it, guys, because this is how you need to, these are the special kind of questions that can be asked. So the better you make mistakes now, the better it is, because you will not repeat those same mistakes in your board exams later. All right. Do you understand the question, Gayatri? Okay, I'll just explain this one more time. What? Alright, option C is correct. For this question, option C is correct. Unfortunately, we have chosen all the wrong. All the answers are wrong according to this. Hold on, people. I know what is happening. Wait, why can't I edit this question? Yes. Option 3 is correct, guys. Option 3 is correct because again, when you have a moving magnet, when the charge is flowing through a conductor, there is a magnetic field also created. For example, if you have a straight current carrying conductor, the magnetic field is going to be concentric circles. So both electric and magnetic field is present when a charge is moving through a conductor. The first statement is true. Why? Because when a charge is placed in a magnetic field, it will definitely experience a force, and if it's perpendicular to each other, then the force would be maximum. So that is true, but statement 2 is not true. Why? Because there's a magnetic field also created. All right. So the right answer is option number B and not any of the above. All right. So anyways, this is a lot better though. It was a good end to the quiz time. We have Sneha on the top still, I believe, because she got it right. No. Sitanshu, the NEET aspirant, is the winner for the last and the final quiz time. Fantastic job, Sitanshu. Second is Sneha, then it's Kevin, followed by, can't read the name, 11 fingers. Then we have Ayushi, I believe. Then it's Nevin, followed by, can't read the name. Then it's Ribbit, Kushi, and Shrishti. Congratulations. Well done, people. So that's the end of the quiz times. We're not done yet because we're only done with 12 questions so far. We still have another 8 more questions to go through because it's the top 20 questions from magnetic effects. So you can leave the Mentimeter, join the session right now because we have some 6 amazing questions left out for you people to solve. Again, all of these are subjective questions. Since you guys know that your subjective questions are very, very important in your term 2 examination because it's a subjective paper, be prepared with these kind of questions also. Now, the first question taken is actually appeared in 4 four different board exams: 2009 board exam, 2011 board exam, 2012 board exam, and 2015 board exam as well. This is a very important question, so listen carefully. State the rule used to determine the direction of magnetic field produced around a straight current carrying conductor. Very simple question, but an important one because it has appeared 4 times in board exams, in previous board exams: 2009, 11, 12, and 15. So be prepared about this one. So tell me, Bill, what is that rule that we use? Exactly, Soham, exactly. It's known as Maxwell's right and thumb rule, or you can simply call it as a right and thumb rule, where what does it state? The thumb shows the direction of current. What is the direction of current is shown by your thumb. The curved fingers, that is, so if you hold a straight current carrying conductor in your hand, right hand, the thumb shows the direction of the current. The fingers that are enveloping the conductor shows the direction of the magnetic field. If current is going in the upward direction, then the magnetic field is going to be in anti-clockwise direction or counter-clockwise direction. What is the spelling of clockwise direction? If current is going in the downward direction, then it's clockwise direction. Then it's going to be in clockwise direction. Telling this autocorrect is spoiled by spellings correct. Exactly. All right. So that is the answer for the first question, guys. The second question again has been repeated in three different board exams: CBSE 2013, 2014, and 2000. So back to back 3 years, this question was asked. The question is: state the rule to determine the direction of force experienced by a current carrying conductor placed in a magnetic field which is perpendicular. Which is that rule that we use to find out the direction of the force experienced by? Exactly, Kushagra, exactly. 4 fingers represent the exactly. Absolutely. It's not amperes, it's Maxwell's right and thumb rule. Absolutely correct, guys. Absolutely correct. It is nothing but Fleming's left hand rule, where what does it state? When you take your left hand and extend your thumb, index finger and middle finger such a way that they're all perpendicular to each other, perpendicular to one another, or they're perpendicular to each other. In that case, the thumb shows the direction of force on the current carrying conductor, the index finger shows the direction of the magnetic field, and the middle finger shows the direction of the current. One of the best way to remember this: father, mother, child, or you can also remember it as FBI, where F is the force, B is the magnetic field, and I is the current flowing through the conductor. As simple as that. So now again, guys, if it is asked a 5-mark question, you can't just state that. You have to explain in your own words. Again, I'll be putting up these notes in today's session, so please download the notes. So again, if it's asked a 5-mark question, then you have to explain it in detail. A lot more explanation has to go into it. If possible, put an example also. Give an example in that, like assume that there is a current going from east to west direction. If possible, right? If you have time, if time permits. If it's a 5-mark question, then go into deeper explanation. But if it's asked a 3-mark question, then explaining about this is more than enough. But if it's asked a 5-mark question, then put in some examples also into it. All right, because it's supposed to be a 5-mark question, right? Okay, 15th question, people. Here's another one. A magnetic compass shows a deflection near a current carrying wire. How will the deflection of the compass get affected if the current in the wire is increased? Support your answer with a reason to it. If you have a magnetic compass near a conductor, you will have some deflection. What would be the kind of deflection if you increase the current flowing through the conductor? And what the more important thing is, you have to support why does this happen, and you have to give the reason for this as well. Exactly, Aditi. There'll be more deflection because why? More current is flowing through it. Now tell me, people, what is this force called as? What is this force? What is this termed as? Or what do you call this as, basically? Exactly, deflection will increase. So how do we show this? We showed it was as Lorentz force. So F is equal to BIL. We know that force is dependent. The force acting on a current carrying conductor depends on 3 factors. It depends on the magnetic field, the current flowing through it, and the length of the conductor. So we know that F is directly proportional to I. So more is the current, more is the force acting on the current carrying conductor. That's it. More is the current flowing through the conductor, more will be the force acting on the conductor, or more will be the force, or more will be the deflection on the needle as well, right? So this is the reason for it, guys. More is the current, more will be the magnetic field. Since the magnetic field is much more stronger, the force would also be much more greater. All right, exactly. It's called as Lorentz force. So again, people, you have to, if it's a 5-mark question, you have to explain it in detail. All right. So we observe that the deflection of a needle of a magnetic field increases because of the magnetic field strength being more when more current is flowing through it, because the strength of the magnetic field directly is proportional to the amount of current flowing through it. And if there's less current flowing through it, then there is lesser force, detected. All right. Here's another one. What is the direction of force acting on the proton? So here the question is, people, what is the direction of force acting on the proton? Again, you have to use your Fleming's left hand rule. Figure out what is the direction of force acting on this proton. Go ahead, guys. Come on. You have to tell me. I'm not going to tell you guys anything. Sure. Hi, Simran. Yes. Da. Sorry. Out of the page. Pakka. 100%. All right. So how do you do this, people? Now here, since they have given proton, which is nothing but positively charged, direction of current will be in the same direction. All right. Magnetic field is going from my left hand side to right hand side. This is the direction of the magnetic field. Current is going in the downward direction because they're talking about a proton here, positively charged. So do not take the opposite direction. It's going in the downward direction. So what is the direction of your thumb? Thumb is facing you, which means that it is out of the page. It is coming towards you, which means that it's out of the page. Super easy question. But again, guys, if you're getting this wrong, that means that your fundamentals are not exactly set yet, which means you have to go through the videos, go through the, go through your NCERT and make it very, very clear. So here, protons are going in the downward direction. That is the direction of the current. Then magnetic field is going from left, right. So thumb is facing you or pointing towards you, which means that it is out of the page. Simple as that. That's a very, very simple, straightforward question. Here's another one, back to back. This was asked in 2010 and 2011. Back to back, 2010 and 2011. Here's a question. A student, while studying the force experienced by a current carrying conductor in a magnetic field, records 2 observations. The first observation is the force experienced by the conductor increases as the current is increased. The second one is the force experienced by the conductor decreases as the strength of the magnetic field increases. Now you have to tell me which of these observations are correct and why is that correct. Go ahead, people. Yes, Gayatri. If it is an electron, see guys, let me just correct this also. If in case of a proton, if they are told you that they are talking about an electron, then the direction of current will be opposite to that. Then direction of current would have been opposite to that. All right. So current would have been the opposite direction. Since they're talking about protons here, you will take the same direction as the proton is moving. All right. That's the difference. Exactly, people. Absolutely correct. Exactly, Manjunathan. Exactly correct, people. So the first thing is definitely true. The first statement is true that when a current carrying conductor is placed in a magnetic field and you increase the current flowing through it, the force will actually increase. But the second statement is wrong. Why? Because we know that F is equal to BIL again, and F is directly proportional to B and F is directly proportional to I, which means that if magnetic field is increasing, force has to increase, not decrease, and hence the first statement is correct, whereas the second observation is absolutely wrong. Why? Because of the Lorentz force formula, which is, this is nothing but what? This is nothing but the magnitude of Lorentz force. The magnitude of Lorentz force is basically measured by this formula, F is equal to BIL, right? So B is nothing but the magnetic field, I is the current, and L is the length of the conductor. So first observation is correct, whereas the second one is wrong. Super awesome, guys. Well done. Next one again from CBSE 2010 question paper, 2010 board exam. The question is, a coil of insulated wire is connected to a galvanometer. What would be seen if a bar magnet of its south pole towards one face of the coil is moved quickly towards it, moved quickly away from it, placed near one of its face, and also name the phenomena involved here. This is a 2010 question which was asked for 5 marks if I'm not wrong. 4 to 5 marks was what was assigned to this question. Very, very important. So pay attention. Tell me what do you think is the right answer, guys. Exactly. Okay, so that is the answer for the last question. Tell me the first one now. If you move this magnet, which is the south pole of the magnet, quickly towards the current carrying conductor, what would happen? Exactly. So current is induced. Because of the current induced, tell me one thing, Manjunath, what will happen in the galvanometer? Because of that current induced, exactly, there will be a deflection. There is going to be a deflection here. First case is that there will be a deflection in the galvanometer. Deflection in the galvanometer. Why? Because we know that when a conductor is placed near a moving magnetic field or a changing magnetic field, there is a current induced. Absolutely wonderful. When you move it away, again, quickly you're moving it away, what will happen to the deflection? What will happen to the deflection of the galvanometer again now? Yes? What is going to happen, people? Oh, is it? Isn't it? That's what these kind of questions are important. That these are board exam questions. Exactly, people. There's going to be a deflection again. But that's what I'm talking about. There's going to be another deflection over here. But this deflection will be in the opposite direction. It'll be in the opposite direction. So initially, first when you moved it towards the conducting coil, let's say the deflection wasn't towards the right hand side. Next time when you move it away, the deflection will be towards the left hand side. So deflection will be there, but it'll be in the opposite direction of the original displacement or original deflection. Third question, what if you were to place this magnet near the coil? What would happen? Exactly, there'll be no deflection at all. I'm good, Gayatri, how are you doing? Chanagidin. Exactly, there'll be no deflection at all, no deflection whatsoever. Why? Because you need a changing magnetic field. If there is no change in the magnetic field, there'll be no deflection at all. Simple as that. Okay, last question. Super easy question. What is this phenomenon named as? What is this phenomenon named as? Exactly, EMI or electromagnetic induction. Also known as electromagnetic induction, or you can also call it as induced current, magnetic induction, or you can also call it as induced current or induced voltage. Any of these terminologies are correct, but the more appropriate term would be electromagnetic induction. That's it. All right. So that is basically your 18th question, people. Again, a very simple question. The next one is another super important question. Time and again, this question has been repeated. That is, explain the working, construction, and also the the working principle of an electric motor. If this is asked, it is definitely going to be a 5-mark question. Most definitely going to be a 5-mark question. Now, since we are very short of time, guys, I've actually explained this in one of the videos, that is DC motor and its working. This entire question I've explained in this video. So one whole video for this one question, very important one. Please go through that video if you have any confusion with respect to the working principle or the construction or even the diagram part of it. I've put it over there, so you can check that video out. The link you will find it in the description. You can also search it, Anoop DC motor and working, and it's working. You'll find it. All right. Please go through that, people. Very important question. It's a short question, because since DC, since generators have been removed, you will most certainly have a question. It's a very important question. Very important question. You would definitely have one or the other question from electric motor part. So please do go through it one more time. Very important. So please don't forget it. All right. You have to promise me, pinky promise, in the chat box that you'll do it. Very important. It's very important. That's what I'm telling you. This is one of the most important questions. I'm not saying that all the others are not important, but there will be one question for sure from this. There will be one question for sure. Either it will be asked as a 3-mark question or it will be asked as a 5-mark question, but for sure you will have questions based on this. Thank you, promise. Thank you. All right. Moving on to the last question, guys. The last question for today, the 20th question. This question was asked in 2015 board exam. The question is, describe an activity to show how a moving magnet may be used to generate an electric current. State the rule to find the direction of the electric current generated in a coil in this manner. So what activity, do you guys remember this thing? What is that? Faraday's experiment. You had this in your CBSE textbook. Do you guys remember Faraday's experiment? So here, when you're talking about activity, describe Faraday's experiment. Describe Michael Faraday's experiment. So what did he do there? What he did was that he took a current carrying coil. He took a simple coil. Basically, he took a solenoid, connected it to the galvanometer, to a simple galvanometer. And then what he did was that he took a magnet and he brought the magnet closer and took it further away. every time he moved the magnet, there was a deflection in the galvanometer. Why was there a deflection? Because there was a voltage induced in the conductor because of the moving magnetic field, and that induced voltage induced a current. Because of the induced voltage, there was a current flowing through it, because of which there was a deflection in the galvanometer. So that is the activity that you have to define over here. Again, this is also a 5-mark question, so there's a lot of writing that you have to do, so be prepared with that. I'm just telling you the gist of it, right? So this is what you have to do. Now, talking about the direction, what is the rule that you're going to use over here? Which rule would you use, people? Exactly, they're talking about EMI itself. So which rule are you going to use here? Exactly, you're going to use what? You're going to use Fleming's right hand rule over here, where thumb shows the direction of force on the current carrying conductor, index finger shows the direction of the magnetic field, and your middle finger shows the direction of the induced current. Simple. So you're going to use your Fleming's right hand rule to figure out what is the direction of the induced current over here. So that, again, 5-mark question. So the whole definition is given over here. They're talking about the whole experiment. It's a really long answer. So this is, you see this though, the answer of this starts all the way from here. A bar magnet is moved towards and away from the from a current carrier. So you see this, when they're moving towards and away, the magnetic field lines are getting intersected, because of which there is a voltage induced or a current induced in the conductor. And they've explained on what are the factors that it depends on. That is basically the strength of the magnetic field, the length of the conductor, and also the speed at which you're moving the magnetic field. All of these are deciding factors. So they're mentioning that also. Then they're also talking about Fleming's right hand rule. The whole definition of Fleming's right hand rule is given over here. So it's a really long answer question. But again, this would come under the category of very long answer type question. Again, a very important one. So do not ignore it. Do not let it slide. Please, I know it's a little long, but it's definitely going to be worth it, because why would you want to lose 5 marks for no good reason? When you know that these are the kind of questions that they are going to ask you, why would you want to lose marks on that? Right, guys? So that's pretty much it, people. That's pretty much it. So I know there was a lot of important questions though, because there were a lot of important questions. That's why I had to become a little serious. But nonetheless, guys, if you enjoyed the session, don't forget to give a like and subscribe to the channel. And on top of that, like I told you people, you also have the Drona batch starting from yesterday. The new Drona batch has started, people. So if you guys want a last set of revision for your board exam preparation, this is an opportunity for you guys to kickstart your preparations right away, because you'll be taught from one of the best set of teachers that you can ever find out there. Abhishek sir, Harsh sir, we have Anubha ma'am, and all sorts of amazing teachers, Amrit sir, Amit sir. All of these are the teachers who will be teaching there. So this is the Drona batch. So if you go to the description of this video, click on Drona CBSE 10 class 10 revision enrollment. You'll be getting lots of practice questions, full revision of all the chapters of all the subjects: physics, chemistry, bio, math, English, social science, until the end of your examination is what you're getting, for a price of 2,970 rupees. And that is after the 10% discount. If you don't use my discount coupon code, you'll be getting it around 3,300 rupees. I'm pretty sure none of you guys want to pay more money. We always want to pay less money for everything. So we have a coupon code for that as well. Use my coupon code ABPRO. I mean, including me. All right, I'm not just talking about you. Even me also. When you want to buy something, you only wait for the sale. No, like for example, if I want to buy something on Amazon, I have to wait for a Great Indian Sale. Until then, I won't buy it. So it's like that. Hey, so use the coupon code ABPRO, get the 10% discount, and on top of that, you can also get 10% discount on MobiKwik and 15% discount on Amazon Cash as well. If you use Amazon Pay, you can get 15% discount over there as well. All right, so that's 2,970 rupees for the entire crash course, people. Fabulous opportunity for you guys to study from one of the best set of teachers, that is Amrit sir, Amit sir, Anubha Gaur ma'am, Ankana ma'am, Abhishek sir, and Harsh Priyam sir. All right, so that's it, people. That's all for today. That is it from my side. If you have any doubts, any questions, any queries that you want to ask me, you can ask me right now. And yeah, who was asking for my email ID, guys? This is my email ID, anup.manoran@vedantu.com. And I'm also on Instagram. If you guys want to follow me over there, it's anup_Vedantu. That's my Instagram handle. You can follow me over there as well. I'll be putting up all the leaderboards of today's session on my Instagram stories. All right. Okay, so that's it, people. That's all for today. Sir, it's bills, right? In the sense, okay, sine theta, we don't learn it right now. We don't use, see, the actual formula, people, of Lorentz forces, F is equal to BIL sine theta. All right, BL sine theta. But the fact is, guys, we are not talking about, see, what is a sine theta? Is nothing but it is the angle between the magnetic field and the current. magnetic field and current is what they're talking about. This angle over there is what they're talking about. So generally we are not considering that angle, especially in 9th standard, in 10th standard, we don't consider it. That is why we're ignoring this part. But in your higher grades, you will be learning the complete formula. It's actually BIL sine theta. So sine theta is nothing but the angle between the current and the magnetic field. Now, if in case, please remember this one factor, guys, that if magnetic field and current are both parallel to each other, then the value for F will be 0, because it will be sine 0. No, the angle is 0, sine 0 is nothing but 0, so the whole term becomes 0. All right. Maximum force that you get is when your magnetic field and current is perpendicular to each other. When they're perpendicular to each other, in that case, the force acting on the current carrying conductor will be maximum. All right. So remember that. All right. Okay. What is it? What builds? Okay. No, over there. Okay. You can say that. I mean, it's based. Oh, if you talk about EMI, okay, my bad. I read it as this thing. So if you're talking about EMI, then it's the strength of the magnetic field. It's the length of the conductor. That is length of the conductor, the strength of the magnetic field, and it also depends on the speed at which the velocity of the magnet, at what speed you're moving the magnet. That also matters. All right. What in this chapter, but why do you block you? What? So this chapter is very why Antara? The chapter is actually pretty good. So electromagnetism video is not there for ICC on YouTube. Manjunathan, do one thing. The electromagnetism, you can go through the CBSE videos itself, because CBSE videos are actually the CBSE syllabus that you have for magnetism, no, is very similar to ICC. So few of the concepts you will have it, but there are few things that you won't have it, like EMF and all that you won't have it. EMF and terminal voltage and all that, both for electricity and magnetism, no, that is not a part of CBSE, so we have not covered that. But I have actually made the one-shot videos of that for ICC students. I've made the one-shot videos of EMF, terminal voltage, internal, resistance and all that. I've made that separately. But for both electricity and magnetism, you can go through CBSE otherwise, because the syllabus is almost the same. Not exactly the same, but almost the same. All right. So you can go through that. All right. Okay, Gayatri. Bye-bye. That's what. So yeah, EMF and all that we have not. So CBSE students, we don't call it as EMF. We just call it as voltage. But for ICC, we have something called as EMF, terminal voltage, and all that. So we don't call it as. We just call it as voltage for CBSE. That's the only difference. All right. It's a good chapter. It's a good chapter. But again, it's all about. Matte means what next? Or then what? It's like that. It's Kannada. So come with more questions. Exactly. We'll be we have another session. So this week, like I told you, this week we have one more session. I'll be coming live this week, the whole week I'll be coming live. But if I'm not doing it this week, the next week again we'll have 20 questions of magnetic effects. All right. We have done 20 questions, of 40 questions in total we've done for electricity chapter, and here also we'll be doing 40 questions for magnetism as well. So don't worry, everything will be covered. Don't worry. Yeah, Nidhi, sorry, nobody is ready to buy my kidney now. No, because of recession, nobody wants kidney anymore. Why? That's what. See, it seems like your zindagi is becoming, what is that? Yeah, these chapters are creating a lot of ruckus, creating a lot of tabahi in your life, but it's actually very interesting. The fact is, guys, in the future, the whole life depends on this. Like, I'll just tell you the importance of this chapter. See, you guys have heard about Shanghai Maglev Vision, all right? The world's fastest train. Robotics these days, it's become a very big deal, right? Robotics, everyone knows that the whole scenario of manufacturing is turning into robotics. But without electricity, without understanding the basic concepts of magnetism and electricity, none of these would work. Right, so it's for the future. All right, all the things that you're learning right now is gonna, is gonna matter a lot when it comes to when you actually, because the whole future depends on this. So think of it like that. Think of it as gaining information, gaining knowledge for your future. All right, don't think of it as a way to just start. You're just mugging it up just for your boards. Don't do that to yourself. All right, don't restrict yourself to that. All right. Oh, you have Gopal's session now. No, I did. I put on Craigslist. I put on Ola also. So what is that? OLX. I put my kidney on OLX. For buying an iPhone, but nobody bought it. They thought it's a fake news. Put on OLX also. OLX India, OLX International. I put it everywhere. Yeah, say something in Marathi. I don't know any Marathi. Teach me some words, then I'll speak in Marathi. Don't worry. Anyways, I did. Go search Anoop kidney. You'll find it. Go search, you'll find it. Anyway, so people, thank you for joining today's session. Please go attend the other sessions that you have, on the platform. Do not forget to subscribe to the channel because we'll be coming with more, more awesome content like this for your preparation for your boards. And we'll be starting with the Sprint Tech series, Marathon series, everything and anything to help you prepare for your boards better. We'll be doing that. Whatever is possible from our side, we'll give our 110%. Doesn't matter what's happening outside, whatever pandemic is going on, we'll make sure that you are getting your 100%. We'll make sure that we're giving your 100% to you guys. All right. So I'll catch you guys later, people. Yes, Nidhi, take care. Bye-bye. Bye, everyone. See you all. Have a fantastic day ahead. Subscribe, hit the like button if you guys enjoyed the video. And yes, you can follow me on Instagram. This is my handle and this is my email ID, anoop.banaran@vedanta.com. All right. So see you soon. Take care. Okay, see you all. Have a great day ahead and stay safe. All right, give your best. Peace. Wakanda for life. Take care, people. See you all. Bye bye.